The topic of this video is graphing systems of inequalities. Let's look at a problem. Graph the system of linear inequalities. Tell whether the graph is bounded or unbounded, and label the corner points. Let's look at the system. X is greater than or equal to 0, y is greater than or equal to 0, x plus y is greater than or equal to 3, x plus y is less than or equal to 12, and 3x plus y is less than or equal to 15. Okay, so the first thing we want to do when solving a problem like this is to recognize that the top two inequalities are telling us which quadrant our graph should be located in. The quadrant where x is greater than or equal to 0 and y is greater than or equal to 0 is quadrant 1, and the part of the x-axis and the part of the y-axis shown here. So the rest of our attention will be paid to these three inequalities. I will number each one. We're going to graph each one at a time, starting with the one I've labeled number 1. X plus y is greater than or equal to 3. This has a y in it, so we'll solve for y. We'll move the x to the other side, and we'll remind ourselves that when a term changes sides, it changes signs. This is a line in the slope-intercept form, and we notice that the coefficient of x is -1, which we can write as the fraction -1 over 1 x plus 3. This is important because it helps us to see the rise over run, which makes it easy to graph our line. First, plot the y-intercept of 3. Next, use the slope to rise and run to the next point on the line. The rise is -1, the run is 1. If you rise -1, you've gone down 1, and a run 1 is a step to the right. So from here, we go down 1 and right 1, and we put a point on our graph. We can repeat this until we reach the x-axis. Down 1, right 1, put a point. Down 1, right 1, put a point. Now, connect the points together using a straight edge. Remember, we're limited to quadrant 1, so we're creating a line segment here, not an actual line. In other words, it starts and stops at these two intersects. Okay, now the graphing part says y is greater than or equal to. This means that we shade up. So I'm just going to draw a little arrow indicating that the region that we're looking for is above this line. Okay, so that was inequality statement number 1. Let's move on now to inequality statement number 2. X plus y is less than or equal to 12. The algebra will be very similar. Move the x to the other side. Rewrite the slope as a fraction. Plot the y-intercept, this time at 12. Rise and run using the same slope as before. Down 1, right 1. This time we have a longer journey and we need to be careful. So we go down 1 and 1 to the right. We're now at coordinates 11, 1. Down 1 and 1 to the right, we're at coordinates 10, 2. Down 1 and 1 to the right, we're at coordinates 9, 3. Down 1 and 1 to the right, we're at coordinates 8, 4. Down 1 and 1 to the right, we're at coordinates 7, 5. Down 1 and 1 to the right, we're at coordinates 6, 6. Down 1 and 1 to the right, we're at coordinates 5, 7. Continuing this trend, we're at 4, 8, 3, 9, 2, 10, 1, 11, and 0, 12. I just realized I said all of those numbers backwards. So this is 1, 11, 2, 10, 3, 9, 4, 8, 5, 7, 6, 6, 7, 5, 8, 4, 9, 3, 10, 2, 11, 1, 12, 0. Okay, now use a straight edge to connect all of your dots together. Alright, I'm going to adjust some of these because some of these dots didn't come out so great. Okay, now comes the shading part. This says y less than, so we shade down. Actually, it says less than or equal to, but the result is the same. So we're going to shade underneath this line. All right, inequality number 3. We have 3x plus y less than or equal to 15. Moving the 3x term to the other side, y is less than or equal to negative 3x plus 15. Y is less than or equal to, negative 3 can be written as negative 3 over 1. So this is the equation of our line. Y is less than or equal to negative 3 over 1, x plus 15. All right, first we plot the y-intercept of 15, which is here. Okay, from that y-intercept, we want to go rise negative 3, which is down 3, and then run 1 to the right. So down 3 and 1 to the right would put a point here. Down 3 and 1 to the right would put a point here. Down 3 and 1 to the right would put a point here. Down 3 and 1 to the right would put a point here. And down 3 and 1 to the right would put a point here, our x-intercept of 5. All right, let's connect all of those points together. And the shading part. Y is less than or equal to, so we shade down. Okay, so now that we've drawn all 3 of our lines, we have to find the shaded region, which is the overlap of all 3 shaded regions identified. This is the place where all of the arrows are pointing. For example, above this line, below this line, below this line, in quadrant 1, and therefore we're looking at this shaded region right here. Okay, this is a shape with 5 sides, 1, 2, 3, 4, 5, which means it also has 5 corners. Now, part of the instructions for our problem say we need to graph the system, which we have done, tell whether the system is bounded or unbounded. It is bounded because we can draw a circle around our solution region. This 5-sided shape can fit within a circle, and label the corner points. So, as is often the case, 4 of the corner points are easy. It's the 5th one that's tricky. So let's go ahead and label those corner points. I'm going to change colors so that they really stand out. So we've got this point right here, which has an x-coordinate of 3, and because it's sitting on the y-axis, it has a y-coordinate of 0. So 3, 0. We have this point right here, which has an x-coordinate of 5, so that's 5, 0. We have this point right here, which is a y-coordinate of 3, and sitting on the y-axis, meaning x is 0, so that would be 0, 3. We have this point right here, which has a y-coordinate of 12, so this is 0, 12. And then that brings us to this point right here. This is the tricky one. This point does not fall at the intersection of a row and column line from our graph, which means to locate that point, we're going to need to solve a system of equations for the intersection of these 2 lines. The line that has an y-intercept of 12, which is this line right here, and the line that has a y-intercept of 15, which is this line right here. All right, so let's go ahead and do that. Let's clear some space. We'll find the 5th corner point. Remember that with inequalities, you have a symbol like greater than or equal to, or less than or equal to. The equal to is the line. The greater than or less than is the shading. We're looking for the intersection of these two lines, which means we are only interested in the equals part. All right, so let's go ahead and write this down. So this line right here, the equation of this line was y equals negative x plus 12. And the equation of this line right here had an equation y equals negative 3x plus 15. All right, so we need to find a way to solve this system. If we can solve that system, then that will tell us the location of the intersection of those two lines, and therefore our fifth corner point. So let me go ahead and label this on our diagram here to make this super clear what we're doing. We've got two lines on our diagram, and we're trying to find the intersection of them. I'll highlight them both in brown. So this line right here, and this line right here. All right, so here we go. What I notice about this particular system is that both equations start with y equals. So therefore, if I want to solve the system, I can actually set the two right sides equal to each other. In other words, if y equals negative x plus 12, then I should be able to put that here in the other equation as my substitution. So I get negative x plus 12 equals negative 3x plus 15. I'm going to move all x terms to the left and all number terms to the right. When a term changes sides, it changes signs. So negative x plus 3x is going to equal negative 12 plus 15. Negative x plus 3x is 2x. Negative 12 plus 15 is 3. So x equals 3 halves. Okay, so now that I know what x is, I need to figure out what y is. I can plug into either one of these equations to find that out. I'll plug into the top one here. Y is negative x plus 12. Therefore, in this case, y is negative 3 halves plus 12. Let's find that as a single fraction. 12 is the same as 12 over 1. Get a common denominator. Multiply top and bottom by 2. So then this is negative 3 over 2 plus 24 over 2. To add the like fractions, keep the common denominator, then add or subtract the numerators. In this case, we're adding. Negative 3 plus 24 is 21. So when x is 3 halves, y is 21 halves. This gives us our fifth corner point. 3 halves, comma, 21 halves. You'll notice that I kept with fractions throughout the entire problem. I never changed to decimals. Here's the reason for that. Sometimes you can change to a decimal if it's an exact value. For example, 3 divided by 2 is exactly 1.5. The decimal terminates. It stops. It doesn't require rounding. But that will not always be the case. For that reason, I've decided to stay with fractions throughout this problem so that no matter what kind of problem you face in the future, you'll be able to get an exact correct answer.